This is lesson 6, day 3, only the second video. We finished solving radical equations. These are nothing new. You guys don't have to copy these down. As in, you guys already have them from last time.
Oh.
I realized that I accidentally gave you a problem that dealt with what we're going to deal with today. And that is a radical on both sides, or there are two radicals in the same problem. So I brought these back just because I want you guys to realize that they are applicable to this problem. I think that's the right word, or maybe not. But basically it comes down to, you separate the radical from all else. If there's more than one, separate them each on their own side. Now, it was brought up in the last hour, do I have to? And the answer is actually no, you don't. But because you're going to have more than one thing on a side, you can't just square each term and call it a day. You actually are going to have to square a binomial. And when you square a binomial, you can't forget to use the 4-letter F word, FOIL. So you're going to have to FOIL one of your sides. I would rather FOIL something with a number and a square root than to FOIL something that has 2 square roots in it. Because then I have to multiply square roots together. I have to get rid of square roots. All this stuff that could really get messy. Okay? Then, as you said, too, we're going to correctly apply the power to each side. And if that doesn't resolve the fact that I got rid of all radicals, then I'm going to go back to 1, separate again, and then 2, hit it with a power, so therefore I get rid of it again. At most, I think we should only have to do this twice. The first time gets rid of one of the radicals. The second time gets rid of the second radical. Okay? So this process now just becomes more involved, as in it just takes another step. Of course, you're going to solve for the variable. 4, I think I added 4. If anything, you have to put 4 in there. I forgot for some reason. I think I talked about it but didn't do it. You need to check for extraneous solutions. Remember, extraneous solutions is you're doing everything correctly. You're adding to both sides, you're dividing, you're squaring, you're square rooting, all of that. It's just that your imaginary friend is reaching over and saying, hey, 5 is an answer. So you write it down. As in the math tells you it's the answer. But when you go to check it, it actually doesn't work. So you have to check your work. Check, 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 check every answer. Make sure that it does. Okay? Moving on. Oops, backwards. That way. That's the problem. So this is the problem that looks a lot like problem number 8, which was in your homework from the other day. I told you guys to save it. That's for today. I have the square root of s minus 48 plus the square root of s equals 8. Now, honestly, if it was me, I would not necessarily choose s to be a variable. It gets really easily mixed up with what number? 5. So just kind of make your s's more italicized or something. Some way to kind of distinguish, make them a little bit funnier looking. A little more curvy, right? Or change it to x's. I like it. But here's the problem. If the problem is asking you to solve for s at the very end, don't put x equals.
Change it to s back.
On a quiz or a test or something, right? You have to realize that you changed the variable, you better put it back. Okay. So, step number 1 said, separate your radical from all else. If there's more than one, separate the radicals. Okay, guys, what I was talking about, could I just square both sides? The right-hand side is 64. We like that. But here's the problem. That square cannot be distributed in. Guys, this property, you guys remember this one? Your exponent property? That only works if what is in between A and B?
Multiplication.
Multiplication. Is that what's happening up here?
No, sir.
No, it's adding. This, guys, is not distributing the n as a power. That means it's a plus b times a plus b, however many powers it is, right? So that's huge. Be careful on that. Don't do that. To make us easier then, I said separate. Easiest way to separate is to move which one?
S.
The s, or the square root of s, right?
Yeah.
So if I minus square root of x from s from both sides, it'd be s minus 48 with the square root equals 8 minus square root of s. Would you guys agree?
See.
Okay. This is going to get interesting. Bless you. Now, I got them separated. Step number 2 says what?
Apply the correct power to cancel.
Okay. These are what kind of radicals?
Square root.
Square roots. So you're going to what both sides?
Square.
Square.
Wait. Wouldn't that just be the same thing? Because
Right. What happens with a square and a square root?
cancels, right?
That cancels, right?
Yeah.
So this side is s minus 48.
Why can't you do a square root now? Because that addition sign.
Because
You couldn't do it before, but now you can.
you could have done it before.
Oh.
But you would have had to square a binomial that had 2 separate square roots. And if you remember how to FOIL, you got a first, outside, inside, last. You would have a square root times a square root, and then you'll have some like terms in there that you'll have to add up. I don't want to deal with that kind of mess. So instead, I'm going to FOIL 8 minus the square root of s. Would you guys agree that 8 minus square root of s squared, I can get rid of the 2 as long as I wrote 8 minus the square root of s. Again. Now I agree, this is not perfect. This does not get rid of the square root. But it's going to make it better. What's 8 times 8? So it's 64. What's 8 times a negative square root of s?
Positive fourth root.
No.
Nothing.
It's negative 8 square root s.
Oh.
You seeing that?
Yeah, I get that.
One's inside a square root, one's not. So when I multiply them, I have to leave the 8 outside. What's a negative square root of s times 8?
8, negative 8.
It's a negative 8 square root s again. And then, what's a negative times negative? And so it's square root of s times square root of s. It's just s, positive, right? Because everybody follow foiling. First, outside, inside, last.
Yeah.
Now, I had about half of you guys 2 years ago. We learned how to FOIL at that time. We also learned that there are times where your numbers end up finding a pattern where it's a plus b squared. And when it's a plus b squared, it fits a perfect square binomial. I said, hey guys, there was a special pattern to this. It's the first one squared. It is this last one squared. But then you have to multiply a times b and multiply it by 2. Do you guys remember that pattern?
No.
Because you know what I did also that year? I followed it up with this idea saying, you don't have to memorize that. Because I don't want you to memorize it. I want you guys to come to your own conclusion that that would actually be beneficial to know. Because I can FOIL, write them side by side, first, outside, inside, last. You got it. It just takes longer to FOIL versus recognizing I have a perfect square binomial. I can expand it using that pattern. So, again, I bring it back up. It's not needed, but I'll tell you what, it's going to make it a lot easier for you if you can remember that formula. First of all, it goes both ways. So, faster way to factor as well. I'm going to erase that. Is that okay? We already got an answer here. But do you guys notice that I probably should gather those two up?
Yeah.
I got a negative 8 of something minus 8 of the same thing. How much do I have? So it's a minus 16 of them. And them are square root of s. We are now done with steps 1 and half of 2, right? Because it really, I guess maybe after step 2 should be simplify. Do we have all the square roots gone?
No.
No, we still have one. So it says when you still have one, repeat steps 1 and 2, right? So step 1 said separate this guy from everything else. So it means get rid of 64 and get rid of s. You guys agree with this or no? Okay. So I'm going to subtract 64 and I'm going to subtract s. Hey, that's kind of cool. What happens to the s's?
Cancel out.
They cancel out. What about negative 48 minus 64? What's 48 plus 64? 112 equals a negative 16 square root of s. Do I have the square root by itself?
No.
Not completely. I got to get rid of what?
16.
Negative 16. How do I get rid of a negative 16?
Divide.
Well, think about it. It's multiplied to the square root, so I'm going to divide by negative 16. Negative, negative makes a...
Positive.
That makes it a lot easier. These are gone. So square root of s is equal to... What's 112 divided by 16? A couple calculators finally coming out. 7. Now I isolated. Now I can get rid of the square root by squaring both sides. And that means s is equal to 49. Cool. I like that. What should I do with that, though?
Circle it.
Circle it? Okay, what else? Bless you. Plug it back in. Guys, I'm not going to go through a whole bunch of hoops to do this. I'm just going to go up here and say, okay, what's 49 minus 48? So that's 1. Okay. And then plus, what's the square root of 49?
7.
Does that equal 8? Yeah. So 8 equals 8. So therefore, check is definitely 49 works.
All that for 1 plus 7.
What do you mean? That was checking it.
Right. So like,
We did all of that work to get s is equal to 49. Now, guys, the whole reason is, what if you did all of this and you found out s is equal to 49 and it said s is equal to 10? Well, then you can do 10 minus 48. That's negative 38. What's the square root of negative 38? Not a real number. Guess what? 10 doesn't work. Not square rooting negative numbers. Done. So 10's out. So that would be considered, if it came out that way, that would be an extraneous solution. What happens if 49 is the only answer, right? And what happens if 49 doesn't work? Then that's not a solution. Therefore, there's no solution. Okay?
makes sense.
It should make sense. Always check your work when dealing with rational and radical equations. Are we good?
Yeah.
Last topic of 6. Systems of 3 linear equations. Okay, guys, we've done this before. Algebra 2 for sure, we've done this. If we have 2 unknowns, or say 1 unknown, how many equations do you need to solve?
2.
1 equation. If I have 2 unknowns, how many equations is what I need? 2. If I have 3 3 unknowns, I need 3. If I have 10 unknowns, I would need 10. Every unknown variable has to have another equation. That's unique. We have a couple different options. We have substitution and we have elimination. Think of this. When I had a 2x2 system, which was kind of the beginning of this, but really technically part of some of that prior knowledge, a 2x2 system, how many times did you use elimination or substitution? Just once. You just combine them in some way to lose a variable. When we have a system of 3 linear equations, you will actually have to do it in 2 rounds. First round gets rid of a variable. The second round gets rid of another variable. So you are down to 1. So you just keep on going. Why is there a space in that last equation? There's no z's. It's kind of having a placeholder, isn't it?
Yeah.
Notice that it's x, y, z. It's all in order, as in there are columns. It's important, especially if you're going to use the method of elimination. Guys, x, y, z itself is a point. It's the point of intersection between 2 or 3D linear equations. Essentially, 3 different planes. Guys, your desk is a plane. A 3-dimensional goes in all directions, but it's flat. The board is another one. And if I intersect 2 planes, you will form a single line. If you intersect a third plane to that, you could potentially all meet at a single point, an x, y, z. And that's what we're going to solve. So, process. Get rid of the same variable twice. In this case, what's already missing in one of them? So guess what? Half my work's done. I just want to get rid of z again. What's the easiest way to get rid of z again? Add not to both sides.
Cancel each other out, I think.
How?
Because one's negative, one's positive.
Elimination.
But by adding the equations. Not both sides. If I took the first 2 equations and just add them down, right? 2x plus 3x is 5x. What's 2y plus 3y?
5y.
Negative z plus z. Gone.
There's nothing.
And 14 plus 16? 30. Do you guys see that now I have a system with x's and y's? I have 2 equations, 2 unknowns. So you should be able to solve that.
Yeah.
This one actually lends itself kind of nicely to substitution. I could add 2y to both sides. So x would equal 2y. And then I could substitute it in for x. Solve for y. I personally like elimination. So how could I use these numbers to my advantage to get rid of one of those variables? Multiply by 5? No.
You make one equal to 0.
Make 1 equal to 0. How?
Make x equal to 0, and then you solve for y.
Okay, so how are we going to get, how are you going to get rid of those x's to make them a 0? It's not multiplying by 5. It's by negative 5.
Yeah, we'll well, after I know.
Okay. Do you guys see that if I took this equation here, the top one of the new system, and then multiplied by negative 5, it'd be negative 5 times x, which is negative 5x. Negative 5 times negative 2 plus 10y. And negative 5 times 0, 0. Add them up. What happens to the x's?
They're gone.
They're gone.
We engineered that to happen, didn't we? 5 plus 10.
15.
Y equals?
30.
To get y by itself?
Wow.
Divide by 15. Y is equal to 2. Now, guys, now that you have y equals 2, we're going to backwalk. You're going to take the answer that you found and put it into the system that only had x's and y's. Solve for x. And then once you get x and y, you can go back to the originals, that x, y, and z, to solve for z. Would you guys agree that this third equation, the one we never really officially did anything to, well, we did the second time, it only has x's and y's? And it's equal to 0?
Yes.
That's the same equation as this one. It's just that this one I'd multiply by -5. I'd rather use the original. I'm going to put it there. So it's going to be x minus 2 times 2 equals 0. Or x minus 4 equals 0. Or x equals
0.
4. Now that I have x and y, I'm going to place it in top or bottom. First or second equation? I think I'm going to go with the second.
I go with the second one.
Because they're all positive.
Yeah.
So that's the only reason. 3 times 4 plus 3 times 2 plus z equals 16. What's 3 times 4? Plus?
6.
Plus? Equals? 16. That's 18 plus z equals 16. Subtract 18, z equals? Awesome. I have an x, I have a y, and a z. But I can't leave it this way. I need to leave it as an ordered pair.
4, comma.
So it has to be x, y, z. So I'm going to put 4, comma, 2, comma, -2. And there's my answer. Now, if you wanted to, you could check these. Now, this is a system. They should be right if you did the math right. It's not like the last two groups of problems we did. But if I checked them, I have to check them in all 3 equations to make sure that it does work. I can't state just because it works in one that it's going to work in all. Okay, now, we have to be under this common understanding, guys. The common understanding is the fact that this book, that answer of 4, 2, -2, is probably pretty rare. As in, it's not a 1/2, 3/2, and 1/4. Do you guys you get what I'm saying? You cannot be intimidated if you all of a sudden come up with an answer that's 1/2. Or a 1/4, or a 5/3. Those are viable options with what we are doing. Nothing says it has to happen at nice numbers. Okay, so when you get some of those, don't be freaking out, that we can't have that. If you're not sure, check it. Makes sense. Questions? Last one. The last problem here. Guys, all 3 variables are here. They're for you. You need to get rid of the same variable. Just have to do it 2 times. 2 different equations. Guys, options. You can put the first and the second equation together. You can put the second and third equation together. And you can put the first and the third equation together. Don't forget, you can multiply a whole entire equation by 5 or a 2 or a -3, right? So your goal is to say, I'm going to get rid of the x's, and then make it happen, all of them. I'm going to get rid of the y's, or I'm going to get rid of the z's. Looking at this system, which one's probably the easiest one?
1 and 3.
Top 2.
First one.
No, which variable?
Z.
Z. I think z would be the easiest one to get rid of. Why?
The positive and the
I have two of them that have positive z's, and one of them has a negative z. So if I took and added those two together, the z's would be gone. Yeah? But couldn't I add the last two together, and they would also be gone? So do that. Okay. Add them up. What's x plus 2x? What is 2y plus a negative y? Z's are gone. Equals 4. You see it? We need you guys to have a understanding. I want everybody to understand that I added the first two equations together. That's why I drew the line. Everybody got that? I'm going to take this out so I can draw the new line. Now I'm going to add the last two. 2 plus 2 is, so 4x. Negative y plus a negative 2y. Z and the z are gone. And then 1. Not too bad, right? Now which variable do you want to get rid of? No, we got to get rid of a variable, guys. Which one do you guys want to get rid of? We got to solve the problem. Which one do you want to get rid of? No, don't ask me why, guys. Which variable do you guys want to get rid of?
Letter Y.
Oh, the letter Y. Okay.
He is so funny.
I know. Thank you. Thank you.
Did this go into the video?
Okay. Yeah, this is on the video.
That's on the video.
No, and that is too. Okay. Got to get that viewership out. Yeah. Okay, guys. I agree we're going to get rid of the y's. So therefore, I can multiply the top equation by 3. Distribute it through 3 times 3x. 3 times y plus 3y equals 12. What happens to the y's? Gone. 13x equals 13x equals 1. Does everybody get 1 for x?
Hold on, I'm tweaking.
Now that I got x equals 1, I'm going to go back to probably one of those red ones because the other ones have too many. The top one, because they're all positive, that'll work. 3 times 1 plus y equals 4. Plus y is already by itself, right? Kind of. Like there's nothing in front of y as a coefficient. 3 plus y equals 4. What's y have to equal? 1? Now that I have an x and a y, guys, did I always have to get rid of z's first in the very, very beginning? No. It just happened to work out nicely this way, or this way the same time way. Then we can pick one of those top three. Again, for all intents and purposes, probably choose the top one because they're all positive. But I don't have to. So 1 plus 2 times 1 plus z equals 4. 1 plus 2 plus z equals 4. 3 plus z equals 4. Z equals. So the point is 1, 1, 1. Okay? Not so bad, right, guys? Take it, guys, I'm telling you, if you think you're going to guess and check, or if you're going to just power your way through a problem without breaking it apart a little bit, you're going to have struggles. Okay, lesson 6, day 3, page 53, 8 through 12, and 24. Have a great day.
You too.